hydrostatics. You see, a liquid at rest exerts some pressure on any object placed inside that fluid. And hydrostatics is the branch of fluid mechanics that evaluates or studies the pressure exerted by a fluid at rest. And the direction of this pressure is perpendicular to the surface on which it acts. Now, let's look at how to evaluate the total pressure and also the center of pressure. I will explain all of these terms now. What then is total pressure? When we say total pressure, we're actually referring to force here. Total force. It's actually defined as total force exerted by a static fluid on a surface. These surfaces could either be plane or curved. So when this fluid comes in contact with this surface, it exerts a force on that fluid, and that's what we're looking at and we call total pressure. And then we have what we call center of pressure. It is the point of application of this pressure force actually, where the pressure force is actually acting, the point of application of the pressure force. So that is what we call center of pressure, and it's denoted by H bar. Now, understand that the object we mass in fluid, basically, we shall be considering some basic shape of objects. The object can either be an horizontally plane surface, it could be a vertical plane surface, and it could be an inclined plane surface or a curved surface. But let's firstly evaluate the total pressure force. We all know that, first of all, that force, or we say pressure, is force over area. And we can therefore say that force is pressure times area. But we've already concluded that pressure, we've derived pressure to be H rho G times A. We derive pressure to be this. Again, but we know that specific weight is density rho times G. So this can become that the pressure force is simply H times specific weight, this to becoming specific weight, times H. If we rearrange, actually, pressure force is simply simple. Again, actually, we have it that to calculate pressure force for different objects immersed in a fluid, we use F is equal to WA X bar. X bar meaning where X bar is simply distance from the center of gravity of the object to the surface of the fluid. A means area of the object. We understand that W means specific weight. And then F is pressure force. So that's that about that. We have our center of pressure to be moment of inertia over area times the distance from the center of gravity to the free surface of the liquid, and plus that distance from the center of gravity to the surface of the liquid. So, like I said, this is center of pressure. This is how we represent the center of pressure. We have A as the area of the object, and IG is the moment of inertia of the object. So let's look at the moment of inertia of object and center of gravity of different shape with their area as well. So for a rectangle now, having a base, or you say width, and then the depth. The moment of inertia is the base times the width or the depth raised to power 3 over 12. The center of gravity is the depth over 2, so it happens at the middle from here to here. That's the distance. The position of center of gravity is here. So the distance from here to here will be depth over 2. And again, the area is base times the depth, or base times width, whichever way you want to call it. And we have a circle too. For a circle, the moment of inertia is given as pi d raised to power 4 over 64, where d is the diameter of the circle. And the center of gravity is just the diameter over 2. The area is pi d raised to power 2 over 4. That's the area of a circle. Now, for a triangle, there could be other shapes, but our question will not go beyond these shapes given here. For a triangle, the moment of inertia is bh cube over 36, base times the height or altitude over 36, and center of gravity is just the height over 3 from the base, from here to here. That's center of gravity. So, and again, the area is half base times height. Now let's look at various surfaces that can be immersed. Now we look at horizontally immersed surface. What does it mean for an object to be horizontally immersed now? Okay, let me illustrate using this. Okay, this is a phone now. If you immerse a phone in this manner into a liquid, you've horizontally immersed the object. Have it in mind that the position of center of gravity or center of pressure is just the same, because it's just going to be at the middle of this horizontal surface. So that's that about that. We're rarely giving questions on horizontally immersed surface, because the only thing we want to calculate there is just the center of pressure. Nobody has to calculate center of pressure, since we know that it's just the center of the place. So you don't use this formula to calculate center of pressure for an horizontally immersed surface. Now, that's that about that. Now, let's move to vertically immersed surface and solve some examples. Vertically immersed surface now. Let's take an example under this. We have it that a rectangular plane surface is 2 meters wide and 3 meters deep. It lies in vertical plane in water. I've said what it means to immerse an object vertically. If you immerse in this manner, you're immersing vertically. If you immerse in this manner, you're immersing horizontally. Now, we have to determine the total pressure force and position of center of pressure on the plane surface when its upper edge is horizontal and is 2.5 meters below the free water surface. So, if this is the water surface now, this is the object here. And the object is just 2.5 meters below the free water surface. That's what we are told. And now, the depth of this shape, the depth is just 3 meters. And then the wideness, which is the base is 2 meters. Okay. Now, since it was immersed into water, the specific weight of water is 9,810 Newton per meter square. Again, is to calculate the area of this shape. The area of this shape is given as B times D, which is base times depth, which is 2 times 3, 6 meters square. Again, is to calculate the moment of inertia of this shape. That's given as BD cube over 12. And that simply will give us 2 times 3 cube over 12. (4.5 meter raised to power 4). And then the center of gravity is simply the depth over 2, which is 1.5. This is where the center of gravity then should be. Center of gravity. And from here to here should be 1.5. Then from here to the top of the free water surface will simply be, that's my x bar, will be 1.5 plus 2.5, which is 4 meters. So therefore, let's calculate the pressure force now, total pressure force, F, that is WA x bar. And that will simply be 9,810 times the area. And the area is simply 4.5 then times x bar, which is 4. So that will give us 9810 multiplied by 4.5 times 4. 176,580 Newton. Now the next thing is position of center of pressure. That's simply giving us moment of inertia over area times x bar plus x bar. And that will be moment of inertia 4.5. Okay. Oh, is there a mistake here? Okay, sorry, there's a mistake here. This is 6 actually, not 4.5. So this should be reevaluated. So this is 235,440 Newton. Okay, so 4.5 divided by the area, which is 6, multiplied by x bar, which is 4, plus 4. So 4.5, which is moment of inertia, divided by the 6 times 4, then plus 4. This is 4.1875 meter. So that's that for this question. Example 2 on vertically immersed surface. An isosceles triangular plate of base 3 meter and altitude 3 meter is immersed vertically in an oil of specific gravity 0.8. There's no meter here, please. The base of the plate coincides with the free surface of oil. Determine the total pressure on the plate and the center of pressure. Okay, to solve this now, what are we given? We are given the specific gravity of the oil, which is given as 0.8. Now let's put up a diagram for this now. This is the free water surface, and the triangle looks this way, it is immersed this way, so that the base coincides with the free water surface. So that's that. The altitude of this triangle is given as 3 meters. And then the base is given as 3 meters. Okay? Now, the next thing to calculate here, let's get the specific weight of the oil. We know a specific weight of oil. First of all, specific gravity is specific weight of oil over specific weight of water. So on cross multiplying, we get a specific weight of oil is equal to specific gravity of oil times specific weight of water. And specific gravity of oil is 0.8 multiplied by 9810, which is specific weight of water. So this is 0.8 multiplied by 9810. This is 7848 Newton per meter square. Again, the area of this triangle is given as half base times height. Half multiplied by the base, 3, multiplied by the height, 3. This gives us 4.5 meters square. Again, the center of gravity of this triangular plate is measured from the base, is from here down to somewhere here. We get that to be h over 3. The height is 3 over 3. So that's 1. And that happens to be same as the x bar. Since the base coincides with the water surface, from here to the water surface is still the x bar. And that's 1 meter. Next is the moment of inertia. The moment of inertia is given as b h cube over 36. And that will be the base 3 times the height 3 cube over 36. So this will give us 3 multiplied by 3 cube, then divided by 36, 2.25 meter raised to power 4. Now we can go ahead now to get our pressure force. The specific weight of the oil now is given as, we've obtained that to be 7848 multiplied by the area, which is given as 4.5, then multiplied again by the x bar, which is 1. So 7848 multiplied by 4.5. That'll give us 35,316 Newton. The next thing we have is we are looking for our specific center of pressure. And the center of pressure is giving us moment of inertia over area times distance between center of gravity from the center of gravity to the free water surface plus that same distance from center of gravity to the free water surface. Our IG, moment of inertia, is giving us 2.25 all over the area, which is giving us 4.5, multiplied by the x bar, which is giving us 1 plus 1. So we have this to be 2.25 divided by 4.5 plus 1. And this is giving us 1.5 meter. So that's that for this question. Let's take the next example. Example 3 on vertically immersed surface. A circular plate of diameter 1.2 meter is placed vertically in water such that the center of the plate is 2.5 meter below the free water surface. Obtain the total pressure and the position of center of pressure. So let's sketch this now. Let's assume that this is a free water surface and this is circular plate now. The center of the circular plate to the free water surface is about 2.5 meter. That's actually the x bar, which is distance from the center of gravity, because center of gravity is at the middle, then to the free water surface. So that's that about that. Next, we are told that the diameter of the plate, diameter is 1.2 meter, meaning that distance from here to here, just 1.2 meter. So therefore, the area of this plate will be pi d square over 4, and that will be pi times 1.2 raised to power 2 over 4. This will give us 1.13 meters square. We're also given that the moment of inertia is pi d raised to power 4 over 64. So this will be pi times 1.2 raised to power 4 divided by 64. This is 0.1 meter raised to power 4. Again, we know that omega is constant. That is, specific weight of water is constant, which is 9810 Newton per meter square. So let's go and calculate now the total pressure. Total pressure here is giving us 9810 times the area 1.13 times the x bar, which is 2.5. This will give us 9810 multiplied by 1.13 times 2.5. 27,713.25 Newton. And number 2 is center of pressure. The center of pressure is given as moment of inertia over area times x bar plus x bar. Moment of inertia is obtained to be 0.1 all over the area, which is 1.13 plus x. The x bar is 2.5, then plus 2.5. This will give us 0.1, 1.13 multiplied by, this is times, please, by 2.5 plus 2.5. This is 2.54 meters. So that's that for this question.